In this video, we're going to work through one last example of graphing a rational function. In our example here, we'll be graphing the function h of x equals x squared plus x minus 6 divided by x cubed minus 4x. Let's follow the same steps as before to graph our rational function. Our first step is to factor the numerator and denominator and cancel out any common factors. So our function h of x here, let's rewrite the numerator. It's a quadratic, and we want to come up with two numbers that multiply to -6 and add up to +1. The two numbers that multiply to -6 and add up to +1 would be +3 and -2. So our numerator factors as x plus 3 times x minus 2, and our denominator, x cubed minus 4x, we notice that there's a common factor of x in both those terms, so let's pull that out. And what's remaining? Well, x cubed divided by x leaves me with x squared, and -4x divided by x leaves me with -4. And here we notice that x squared minus 4 is a difference of squares, which means we can factor this further. So let's copy down our numerator, x plus 3 times x minus 2. Our denominator is going to be x times, well, our difference of squares here will factor into x plus 2 times x minus 2. And we notice here that there's a common factor of x minus 2 in the numerator and denominator, so we can cancel those out. Now that we're done with our first step, we can move on to our second step, which is to find the x and y intercepts for our function. Remember that if we want to find the x-intercepts, we just set the numerator equal to 0 and we solve for x. And here, we want to work with the factored and canceled version of our function. So setting x plus 3 equal to 0, we can solve this equation by subtracting 3 from both sides to get x equals -3. To find the y-intercept, we evaluate our function at x equals 0. But you'll see that if we try to evaluate h of 0, we end up with 0 plus 3 in the numerator divided by 0 times 0 plus 2 in the denominator. Well, this gives us 3 in the numerator and 0 in the denominator, which is undefined. And so this is just a reminder that x equals 0 is not in the domain of our function. And this also means that our graph will not have any y-intercepts. Let's now plot our x-intercept on our graph. So we plot the point -3, 0. We're now ready for our next step, which is to find the wholes and vertical asymptotes of our function. To find the vertical asymptote, we want to look at the factored and canceled version of our function and set the denominator equal to 0 and solve for x. So we want to set x times x plus 2 equal to 0. Since we have a product of two things equal 0, we can split this equation up into two parts. We have x equals 0 and x plus 2 equals 0. On the left, x equals 0 is already solved. On the right, x plus 2 equals 0. All we have to do is subtract 2 from both sides to get x equals -2. So we have two vertical asymptotes for our rational function. Now, since our function has factors that canceled out in the numerator and denominator, our function is going to have a hole. Remember, we get holes for x values that are not in my domain, that are not vertical asymptotes. Now, x equals 2 is not in our domain because it makes the denominator equal to 0. But it's also not a vertical asymptote, so that tells me that I have a hole at x equals 2. Now, all that's left for this step is to draw in our vertical asymptotes as dotted lines. So we have a vertical asymptote at x equals -2 and a vertical asymptote at x equals 0. Our next step is to find the horizontal asymptote or oblique asymptote. To determine which we have, we want to look at the degrees of the numerator and the denominator. In the numerator, we have a degree 2 polynomial, and in the denominator, we have a degree 3 polynomial. Since the denominator has a higher degree, we know we have a horizontal asymptote, and specifically, our horizontal asymptote is going to be y equals 0. On our graph, we'll plot our horizontal asymptote y equals 0 as a dotted line, and that horizontal line is our x-axis. In step 5, we want to determine where the graph crosses the horizontal asymptote or oblique asymptote. In this case, since our horizontal asymptote is y equals 0, which is the x-axis, we've already found where the graph crosses the x-axis. We found that in step 2 when we found x-intercepts. We know that our graph crosses the x-axis at x equals -3. We already have this point here on our horizontal asymptote. So in this step, we already know that the intersection is at x equals -3, and we're done. In step 6, we want to make a sign chart for our function. So draw a number line, and on our number line, we want to put down our x-intercepts and vertical asymptotes. Our x-intercept is at -3, and then we have vertical asymptotes at -2 and 0. This divides our x values into 4 intervals, and we want to find the sign of our function on each of those intervals. So what we're going to do is pick an x value in each of the intervals, plug them into our function to see what the sign of the output is. Let's start with the leftmost interval here. We want to look at x values less than -3. So for example, we can pick x equals -4. Let's evaluate that in our function. H of -4, we can plug it either into the original function or the factored and canceled version of our function. So let's plug it into the factored and canceled version. In the numerator, we have -4 plus 3. In the denominator, we have -4 times -4 plus 2. Let's look at the sign of the factors. In the numerator, -4 plus 3 is negative. -4 is again negative, and -4 plus 2, that's also negative. So we have a negative in the numerator. In the denominator, we have a negative number times a negative number, so overall the denominator is going to be positive. So if we have a negative number divided by a positive number, the overall result is going to be negative. So since h of -4 is negative, we're going to draw a minus sign on this leftmost interval on our sign chart. Next, we have the interval from -3 to -2. There's no whole number in between -3 and -2, so we'll have to go with a fraction. So for example, we can pick something like -5/2, which is -2.5. So do h of -2.5. In the numerator, we have -2.5 plus 3. In the denominator, we have -2.5 times -2.5 plus 2. The numerator, -2.5 plus 3, is positive, -2.5 is negative, and -2.5 plus 2 is also negative. So in the numerator, we have a positive number. In the denominator, the product of two negative numbers gives me a positive number. So we have a positive numerator and a positive denominator. So overall, our fraction is positive. So on my sign chart, I'm going to draw a plus sign above the interval from -3 to -2. Next, we have the interval from -2 to 0. Here, we can pick an x value like -1. If we look at h of -1, we have in the numerator -1 plus 3. In the denominator, we have -1 times -1 plus 2. The numerator, -1 plus 3, is positive, -1 is negative, and -1 plus 2 is positive. My numerator is positive, my denominator is going to be negative, so the overall fraction is negative. So in my sign chart, we're going to draw a minus sign for the interval from -2 to 0. Lastly, we'll look at the interval from 0 to infinity. Here, we can pick an x value like x equals 1. Let's look at h of 1. This is going to be, in the numerator, 1 plus 3. In the denominator, 1 times 1 plus 2. The numerator is positive, the denominator 1 is positive, 1 plus 2 is also positive. Since all of the factors here are positive, the overall sign of our function is positive. So we draw a plus sign above the interval from 0 to infinity. So that completes our sign chart. Now what we can do is go to our graph and highlight the regions of our graph that are positive and negative. The interval from -infinity to -3 is negative, so we'll highlight that in red. The interval from -3 to -2 is positive, we'll highlight that in green. The interval from -2 to 0 is negative, so we'll highlight that in red. And then lastly, the interval from 0 to infinity is positive, so we'll highlight that in green. So on the red regions, we'll be graphing something that's below the x-axis. In the green regions, we'll be graphing something that's above the x-axis. Now we'll put all the information that we have together to draw our graph. So start with the left-hand side of our graph. The leftmost feature is our horizontal asymptote. Now remember, there are two things that can happen. Our graph can either go towards the horizontal asymptote from above, or it can go towards it from below. From our sign chart, we know that our graph is negative on this region, so whatever we draw, it has to be below the x-axis. So our graph has to go towards the horizontal asymptote from below. So let's draw something that looks like this. Now, the segment that we have will need to connect to our next point that's on our graph, which is this x-intercept. Now, if we keep making our way to the right, the next thing we come across is this vertical asymptote. At this vertical asymptote, we can either go up to infinity, or the graph can go down to negative infinity. Now, on the interval from -3 to -2, we know that our sign chart tells me my function is positive. So whatever I draw, it has to be above the x-axis. Therefore, my graph has to go up to positive infinity. So let's draw our graph going up to infinity at this vertical asymptote. On the other side of the vertical asymptote, our graph has two options. Again, it can go up to positive infinity, or it can go down to negative infinity. But since our sign chart tells me that my graph is negative and below the x-axis, I have to go down to negative infinity. So let's draw our graph going down to negative infinity. If we keep making our way to the right, we come across the other vertical asymptote. And again, our graph might either go up to infinity or go down to negative infinity. On our sign chart, we see that our function is negative between -2 to 0, so we have to have something that's below the x-axis. So my graph has to go down to negative infinity. So let's draw something connecting what we have and then going down to negative infinity. Now, on the other side of the vertical asymptote, our two choices are the graph can either go up to positive infinity or down to negative infinity. This time, on the other side of this vertical asymptote, on the x values from 0 to infinity, my function is positive. So when I draw my graph, it should be above the x-axis. My graph should go up to positive infinity as we get closer and closer to that vertical asymptote. So let's draw something that goes up to positive infinity on the right-hand side of this vertical asymptote. If we keep making our way to the right, our last feature is this horizontal asymptote. And again, our graph has two choices. It either goes towards the horizontal asymptote from above, or it goes towards it from below. According to our sign chart, for x values greater than 0, my function is positive. So I have to draw something that's above the x-axis. So my graph has to go towards the horizontal asymptote from above. So the last segment of our graph would look something like this. Now, one last thing to remember is that my function has a hole. X equals 2 is not in the domain of our function because it would make the denominator equal to 0. This means that our graph does not have a point at x equals 2. So instead of this point here, we're going to replace it with an open circle. And this completes the graph for our function h of x. So in this video and our last two videos, we've learned how to draw the graphs of rational functions.